Good morning, guys. Today we're going to go ahead and look at 12.6 circular functions, and just to let you know, the notes are on eCampus if you want to print them out and then come back and watch the video. So let's get started on this slide here. It's the vocabulary slide, and it's good to know what the unit circle is, which is this right here, where the unit circle is centered at 0, 0, and at 0 degrees or 360 degrees or 2 pi, it's at 0, 1. And then there's a 30 degrees, 45 degrees, 60 degrees, 90 degrees. At 90 degrees, the ordered pair is 0, 1. 90 degrees also known as pi over 2. And then, you'll have the other angles here until you get to another quadrantal, which is at 180 or pi. And the ordered pair is negative 1, 0. Then you go down to 270 degrees. 270 degrees is 3 pi over 2, and it's at this angle, or these measurements here. And then it goes back up. Okay, so make sure you understand the unit circle and the main points of the quadrantal. And I'll show you exactly what a period function is, a cycle and a period with another graph. So let's go ahead and fill in the blanks here. As you know, the terminal side is here is the standard position of an angle, and then it goes, and where it ends is the terminal side. We'll continue to draw those during these notes as well. And then instead of just saying x and y, now we have cosine theta, sine theta to represent x and y. So sine theta would represent the x coordinate, and cosine theta would represent the x coordinate, and sine theta would represent the y coordinates. So instead of this ordered pair of x comma y, now we're going to look at the point P as cosine theta and sine theta. And we'll have to know that in this quadrant, the ordered pair is positive, positive. In this quadrant, the ordered pair is negative, positive. In this quadrant 3, it's going to be negative, negative. And in quadrant 4, it's going to be positive, negative. And that'll help us with the signage of each of these as well. When we're looking for the sine and cosine of a given point, well, here's point P, and they just want us to identify the cosine. So the cosine is the first value in the ordered pair, and the cosine is the second value of the ordered pair. So this is how you would write it. Cosine of theta is the square root of 7 over 4. The sine of theta is 3/4. Would you know what quadrant this would be in? This would be in quadrant 1 because they're both pos. It doesn't ask for the quadrant, but it's good to know that that's where this point would be located depending, on the signage. Okay, so then here we talk about identifying the period, and if you remember the definition of the period in the vocab, it's where a complete cycle is arrived at. So I always start around the y-axis is where I start, where my graph touches the y-axis. So in this case, it's touching it here at the ordered pair of 0, 0, the origin. So I go up, down, right back up where I started. So for us, the way I started it, we would have a period going from that value to that value. So from the period where the pattern starts and ends. So my period starts at starts at 0, and I complete my period or cycle at pi over 3. So that's what they're looking for when they ask what's the period or the cycle. It's the ending value of where your pattern starts. Now, that's because I started at the y-axis origin. If you start somewhere else, well then you would have to do a little different calculations, but for me that would be the easiest starting point. Okay, we're going to look at evaluate trig expressions. So to find the exact value, we got to go ahead and convert this radian measurement so we can understand what the reference angle is. So let's take a look at drawing it out. And I like to work with mine as degrees to get a better picture of where it's located. So I convert this into degrees by timesing it by 180 over pi. When we do the math, we end up with 540 divided by 4, which ends up giving us an angle of 135 degrees. But we're going to go ahead and go clockwise since it's negative. So as I go clockwise, I'm hitting 90 degrees. I don't want to hit the negative 180. So there is my reference angle. My bad, the negative 135 degrees. And that's going to be in quadrant 3. So my signage that I'm going to be working with is negative, negative. And I only care about cosine. So it's going to, my answer is, I know it's going to be a negative value. For my reference angle, you can subtract it from 180. And we get a reference angle of 45 degrees. Also, because the denominator is a 4, that also tells you it's 45 degrees as a shortcut. So when I do my left-hand trick, I end up with 3 fingers, my bad, 2 fingers above my 45 degree on my hand divided by 2, and because we're dealing with quadrant 3, my answer is going to be negative square root of 2 over 2. If you have questions on how to do the left-hand trick, there's a video on that. Feel free to go back and then watch it to help out. So let's take a look at the next example. If I can erase this. Okay, so 420 degrees graph-wise to find out what quadrant it's in is counterclockwise. This would be the 360 mark. The next 90 degrees would be 450, so it's going to be somewhere in quadrant 1, which my signage is going to be positive, positive. And I'm looking for sine. So sine is going to be this, it's going to take this signage at the end. So let's take a look at a reference angle. For the reference angle, I'm going to go ahead and subtract 360 from it. And when I subtract 360, that ends up being 60 degrees is my reference angle. Well, using the left-hand trick for 60 degrees, I'm going to end up with 3 fingers below my 60-degree mark over 2, since it's always over 2. And there is the sine of 420 degrees is the square root of 3 over 2 positive, since I'm dealing with quadrant 1. If you have any questions, please ask in class. Always feel free to rewind. And like I said, if you have any questions, I'm always there for you guys.